So one of the advantages of mass timber is the speed of construction. Can you describe this benefit in your projects? And other than the speed of construction and sustainability, can you also discuss other benefits of mass timber?
I think mass timber has shown itself to be uh, beneficial, comparable to other structural systems because it is what's one of the things that's unique about it is that the way that it's designed and manufactured um, and kind of detailed in the shop before it comes to site is a lot of times there's no other work that has to happen by the time it gets to site. You can simply kind of fit it up. PDX is a great example of this where we have at the underside of the roof, we have 30,000 sticks of 3x6 Doug fir that none of it was cut on site. Everything that needed to be CNC'd, cut to length, happened in a shop offsite, and then even pre-drilled so that when they came on site, all they had to do was take it to its location and screw it in. Then it was done. Um, those were small elements, but even if you're talking about columns or beams, the way that connections are designed today, it's really, um, many beam and column connections are designed to be drop and go. So one of the things I hear about projects is that they can erect a building in a story a day. And I think the bigger thing is um, sometimes the speed that you can put a mass timber together can sometimes outpace the other trades that have to follow along with it. So the challenge there is to find for projects to find ways to sequence it to take full advantage of that. The other thing though about mass timber is that it's a lighter system. And so your foundations, I believe, can be 30% lighter than other structures. So you're having a more sustainable superstructure, but also your substructure can have lower in carbon bodies simply because you're using less of it.
My understanding is that some of the challenges with mass timber are fire resistance or even sound transmission and vibration. Can you discuss how you deal with these issues? How do you tackle the stability of the mass timber under environmental conditions, such as water, moisture, temperature changes?
Uh, Two biggest things that people worry about with mass timber, um, especially owners and their insurance companies. Navigating that has been interesting because while wood has been in buildings for many years, the insurance industry, as of today, does not have a specific category to deal with um, the risk and loss of mass timber buildings. It's something that's under development right now, but um, that's something that the industry still needs to address. From a design and construction standpoint, though, I think it was, I can't remember, I'm going to mix this up. It's either I think it was the 2021 code, maybe it was the 18, um, established, I think it was 2021, established four new categories or one primary category for mass timber. Um, Category four, the new version has type 4A, B, and C. And then there's also an HT. HT was heavy timber, basically was a category four previously. Um, but now mass timbers with the 2021 version, mass timber is now codified. And so there's a prescriptive path that architects and builders can use to craft mass timber buildings. Um, Different jurisdictions have adopted those standards over time. Um, Portland, Vancouver, Seattle are some of the cities that were early adopters and started building. Cities like New York, um, you really couldn't do mass timber until last summer, but New York now allows for only type 4 construction type. Only prescriptive path. They don't allow other performance based, but it's not uncommon for people to use mass timber and use other construct types as well, and kind of alternate means and methods. But wood is, in some ways, wood offers a lot of twofers. It's beautiful, it's strong, and I guess one of its other strength, though, is that it's also self-fire resistant. So you can design it, if you have a structure that requires a 2-hour rating, you simply add more fiber to it. And so the char rating allows you to meet the fire resistance rating and provide for the safety factor you need to safely inhabit a building. Concrete does this very well. Steel, you have to apply fire resistant material on top of it. Now, doing that does add cost. Anytime you add fiber, it is adding cost there, but it is very doable. Vibration, I mentioned the OSU project earlier. That's one that I think people are designing well with, but we're still in this era of gathering a lot of information to kind of optimize what the best assemblies are to deal with acoustics. You can design a frame, we showed at the OSU lab, that can be very rigid and have low vibration, but then there's also the sound transmission component of it. But there are many established assemblies that, well, wood doesn't necessarily do it well on its own. You know, if you combine it with an acoustomat and topping slabs, you're able to dampen those and achieve the kind of acoustic privacy and separation that you'd want to see in a building. Water obviously poses challenges to wood, but if you plan for it, it can be managed. So a lot of times, and I say that coming from the Pacific Northwest, where in Portland we have 160, 170 days of measurable rain a year, it's not uncommon that we're building these things while they're getting wet. But wood, aside from having kind of other sustainable attributes, it's also, I think, has shown itself to be very resilient to water. Yes, if it gets wet, you have to double check that you haven't compromised anything structurally. But what we've seen in the field for projects that have had moisture issues, there's usually a manageable bar to making sure that everything works well. But also contractors are finding unique ways to plan for it and make sure that it doesn't get wet. For instance, they will apply temporary membranes that act as a weather barrier to keep it dry. And then as architects, we always care about how things look. It's not uncommon for wood to be stained by water, metal shavings on a site that stain the wood. But the nice thing about it is that you can clean that up and kind of restore the appearance grade of the wood as well. So by the time the building's finished, it can look new without any undue blemishes.
How is mass timber going to be used in the future, in your opinion? So where do you think it's going, and are there like new technologies being developed regarding this?
Mass timber going to the future? That's a great question. I think the stage that we're in now is we're still in the kind of moving from early adopters to more broad use. I believe that the use of mass timber is growing by 1 to 2% a year, which is pretty fast growth within the industry. I think the most changes that you're going to see and what we're seeing is kind of the standardization of hardware that's used for the assembly and the erection of timber structures. I think the next stage is going to be There's a lot of focus now on disassembly and reuse, because you have these durable manufactured products that they can live in a building for 50, 100 years. But that doesn't mean that they've reached their end of use. There's an opportunity to, if a building we can't increase the intensity use of a building or adapt its use of the building. If it becomes appropriate to demolish it, you can, instead of destructively demolishing it, you could purposefully deconstruct it and use those parts anew in another structure. And if you design for that, you can plan for a way to basically use 100% of that piece over again because the hardware is there to support it. You can still reuse parts today, but oftentimes if you have a 30-foot beam, you might be cutting off a foot or two at the end that can't be reused. Long term, one of my favorite ideas is right now you're seeing a lot of 3D printing of concrete. That is evolving to see more of that in the marketplace. But one of my favorite ideas was kind of doing so with wood fiber. The drawback there is glues are still something that, where possible, we may be trying to live it because of their environmental and health impacts. But someday it'd be really interesting if you could print a timber structure with just the bare minimum fiber that you needed. So if you think of your structural diagrams of moment and shear and designing a beam to be able to take those movements, there was a presentation I saw years ago that it almost looked like Art Deco made out of printed wood, which was really beautiful.